So the oceans are becoming more acidic because we're putting more and more carbon dioxide into the atmosphere, largely through emissions. And what's happening is that the carbon dioxide mixes with the ocean water, and we get something called carbonic acid. And when carbonic acid or any acid is in water, it does something called disassociating. And so you get hydrogen ions, and in this case bicarbonate ions. And the more hydrogen ions you have in a liquid, the more acidic it becomes and the lower the pH becomes. What you can use is a pH meter and a probe. So you collect your water sample, and then you put a probe into it. And at the end of the probe is a glass bulb. And within that are two probes. One of them is encased in a liquid of a known pH, and then your sample is touching the other probe. And basically what this does is it measures the voltage difference between the known and the unknown. And so that then can give you a reading of the pH. So we have more hydrogen in the ocean waters. And hydrogen binds with the carbonic ion to create HCO3 ion. And it's this carbonate ion that shellfish, hard algae use to form that calcium carbonate shell. And so the problem is with increased hydrogen ions in the water, the shellfish or organisms are competing with the hydrogen for this carbonate ion. And so there's less and less of it. They have to expend more energy to build their shells, right? And therefore they spend less time trying to find food. So what the trend has been is that organisms are not growing as quickly. More can die at a younger age. And then there's very serious impacts up the food web, because organisms that eat the shellfish don't have as much, they're smaller, right? And then fish that eat those fish and so on. And 1 out of 7 people rely on seafood for their main source of protein. So then you're looking at major impacts to the human population.
Shellfish is one of our most valuable fishery species right now. Both sea scallops, of course, are the #1 valued single species fishery in the whole country. Surf clam, ocean quahog, the invertebrates, lobsters, and so forth. It's actually a pretty healthy component of the economy right now.
There's actually been documentation of warmer water temperatures causing changes in the fish trawls. So here in Connecticut, in Long Island Sound, researchers are finding more warm water species as opposed to the colder water species. We've already lost the lobster fisheries here, and it's being lost throughout New England.
It's very sad.
But blue crabs have become a real recreational fishery. And so as the water's warm, we can't just look at the negative, perhaps we can see some of these changes as a positive. So there was recently a very interesting article in Nature Climate Change in 2015 where researchers looked at these different ways of actually removing carbon dioxide from the water. Very, very expensive, very time consuming. And basically, through their analysis, they found that it really was not worth the expense or the time. And that what really has to happen is we, as a global community, need to reduce our carbon emissions in order to have some impact.
What what we do at NOAA Fisheries on the science side, one of the things we're doing is trying to get a really good handle on vulnerability of different species, how they would be affected by an increasingly acidic ocean. And like most large-scale climate change issues, there's winners and there's losers. So we're seeing some distributional changes, certainly. We're seeing some changes associated with when at the lower level of the food chain with phytoplankton that really fuels the whole ecosystem, changes in when those blooms occur, changes when the food's available. And so really looking at the species we know the most about, how are they most likely to be affected if the ocean becomes increasingly warm, one of the side effects of that being increased acid.
It's difficult because we have, political leaders who still do not believe in climate change, who believe it's a hoax. And until we get the buy-in at the national level, all we're doing is, working at the local level and regional level, trying to advance both adaptation and mitigation. In New England, there's something called NECAN, which is the Northeast Coastal Acidification Network. And this is an attempt to work with the New England states and do workshops really focused on the fisheries industry, so shellfishing, for example, to present some of the scientific findings for them, to show what some of the shellfish, the aquaculture businesses are doing with regard to pH. And there's been some really interesting work that's being done. What they're finding is that it's really the juvenile stage in many of the harvestable shellfish that is most susceptible to ocean acidification.
Anything that doesn't move around a lot, that either can't move around a lot or that has a very specific habitat or food requirement, because they are the most constrained to being where they are.
Right.
Other species, if they're more omnivorous, they eat a lot of different things, they can move. They'll go looking for water and habitat that are important to them.
So this did occur before, and there was a die-off of some invertebrates within the oceans, including some deep-sea invertebrates. However, it's this rapid rise in the CO2 levels that have never been seen before.